Hey everyone, and welcome to Dr. Abu R10 Academy channel. Today we are going to discuss part 2 of seminar 5, of the University of Debrecen in the Biostatistics subject. So this problem is a straightforward problem, and it's a good start actually for this normal distribution. In a population, the brain volume is distributed according to the normal distribution. He did not say standard normal distribution. He said only the normal distribution, which could have any mean and any standard deviation. It is not standard normal distribution. No, it is not. It is not. So it is normal with a mean. So he already gave us the mean here. The mean value is 1400. If it has a mean different than 0, so it is not a standard normal distribution, because the standard normal distribution, its mean is 0 and the standard deviation is 1. So here mu equals 1400. What about the standard deviation? He said the standard deviation sigma equals, be careful, sometimes he will give the variance which is square, so be careful of it. We need only sigma, not sigma square. So 1125. So what is the probability that randomly chosen individual will have the brain volume smaller than this one? So let us just plot it here, or he already plotted for us. So here the mean was 1400. So here coming to the mean, which is 1400. So this is our mean, 1400, and I drew the curve. This is the normal curve. This is not the standard. This is the normal distribution. It's not the standard. So he said here, what is the probability that the individual have the brain smaller than 1400? So I come here and put 400 and go perpendicular line, straight line, up to here. So this is all the area which I want. Always the area from the minus infinity from the left until we reach the point. So this is the area, which is straightforward. But the problem, I don't have this area. I cannot get this area. So how I can calculate? I have to convert it into standard normal distribution. Standard normal distribution. Then I can use the standard normal distribution table. So how can I do this? It is very easy and simple, since you understand the basic. So what is the question here? The question that he's asking, x smaller than 1400, smaller than 1450. So what I will do, if you remember, I want to convert x into z. So z equal x minus mu divided sigma. So every side here, forget about this formula if you don't want to remember it. So by practice, it will stick in your mind. So I have x less than 1450. So just I say here minus mu divided sigma. And here minus mu divided sigma. That's it. So x minus mu divided sigma is z. So I replace it with z. Z is less than 1450 minus mu is 1400 divided sigma, which is 125. So z will be equal 0.4. So in this case, I have the standard normal distribution. The standard normal distribution. Mu equals 0. Sigma equals 1. So I want all the area z less than 0.4. So here, this is 0. 0.4 will be where? So mu equals 0. 0.4 will be here. So I have all the area, which is, don't get confused and say because it is 0.4, it is less than 1, so I put the other side. No, here mu equals 0. So anything positive, it should be on the right side. Anything negative, it should be on the left side. So 0.4 is positive, so I must have 0.4 and here, so up to this area. So I can get it from the standard normal distribution table now. I go to and check z less than 0.4 and get the probability. So here, once we look at this normal distribution graph, the mean is 0 because it is a standard normal distribution. So I look at the table here, the mean is 0, just to make sure. If I have only one column, so it's easy. If I have all the columns, I just make sure that I'm setting the right mean. The mean equals to 0. sorry, this is the standard. This is the standard normal distribution. So the mean always equals to 0, and sigma always equals to 1. So here I come to this table, okay, and check what is the integer. The first integer, the whole number here. The whole number is this different color. The whole number is, I want 0.4. Z equal 0.4. Okay, the whole number is 0. Okay, so I check 0, and the fraction is 0.4. So 0.4. So I can get the number. So this will be the probability of Z equals 0.4 equals 0.655554. Okay, so this will be the probability. Conclusion: the probability of a randomly chosen individual will have the brain volume less than 1450 is 0.6554. So sorry, just a correction here that I have here, 0.4, Z equals 0. There is no more decimal places after that. It seems that I have said the way I always talk about the whole integer number. Sorry, here there is no more decimal places here, so it is only 0.4. So I come to 0.4. Do I have 0.41? If I have 0.41, I have to go the next level. So it will be, I have to go to the 100. One in the hundredth. So I have to check the hundreds and get it also here. If I want to get thousands, I can and so on, or more than 0.42 and so on. So I can go and continue 0.42, 0.43, 0.44 and go here. But since it is 0.40, so 0.4 and here 0, so this is the answer. As we can see here, the probability of this area, which is less than 0.4, see, we are reading always the normal distribution, reading from the minus infinity, from the farthest left up to the point. So it's calculate all this area, okay? All the area from the left, from the minus negative infinity, okay? Up to here, okay? So if I want to get the right area, which is more than 0.4, for example, more than 0.4, I think this is coming in the next example, the next page. Let us go through it. So here, in this example, he said, what is the probability that randomly chosen individual will have a brain larger than 1450? Okay, so the same thing which I have here. Okay, this is 1400 and 1450. So he wants this area which on the right, but I cannot have it because I have to convert it into standard normal distribution. So after converting it, I have already converted there. So I have already converted and they're really good because it is the same value, which is 1450, 0.4. So I can use the same graph which I have here, 0.4. But now he wants the area which is greater than 1450. This area. I have 0.4, I can get from the table up to 0.4, which will be everything to the left. Okay, but I want the right. So the total total probability under this graph equals to 1. So I have to say 1 minus the probability which I have got here. So what is the probability which I have got for the up to 0.4, from the minus infinity up to 0.4 here, all this area? It was 0.6554. So in this example, it is a simple one also, the same principle. So I have also here 1400, this is my mu, and I have my sigma, which is 125. So he said, what is the probability that the randomly chosen individual have a brain volume between 1300 to 1500? So x is greater than or equal to what? So let us just leave a space here before x. Okay. Or after x. So x is greater than 1300 and it is less than 1525. Okay. $1,525. Okay, so this is x. X is greater than this 1,300 and less than this amount. Okay, so how can I deal with this? As I said, we need to convert it. So here, if we plot this graph, so this is the mean which we have here, which is at at 1400. Okay, this is the mean at 1400, and I want to get it between 1300 up to 1500. Okay, so it has to be this area with shaded. Okay, so I don't have this area, I cannot calculate, I have to convert it into standard normal distribution. Without converting into standard, so I have to do some standardization. Okay, so in order to do this standardization, I have to subtract here minus mu divided sigma. So here minus mu, which is 1400, divided sigma 125. Here minus 1400 divided sigma, which is 125. So here it will be, I can replace this x minus mu divided sigma by z, okay, greater than, less than. So here 1525 minus 1400 equal 125 divided 125 equal 1. So z is less than 1, and here if we calculate this one, minus 100 divided 125 equal minus 0.8. So that will be between minus 0.8 and 1. Okay, so on this graph, if we consider this is the standard normal distribution, so z will be between minus 0.8, okay, which is here, and 1, so it will be this area. The standard normal distribution table will not give me I want this area, only this area. Okay, it will not give me the area to the right of this line. Okay, so what I have to do, I have to get the area to the farthest one, the biggest one. So the area up to here, which is 1. Okay, I check the area up to 1, so it will give me all the area to the left. Okay, all the area to the left. Then I get the area up to 0.8, so it will give me this area. I subtract the probability of 1, which is everything, minus the probability of 8, so I'll get this area. This is the concept. So here in this example, because we have to convert it into standard normal distribution, but here just trying to explain to you that the area up to this one, it will be all the area to the left, all the area. And then the area up to here, it will be all the area to the left. If I subtract this, all this area minus this area only, so I end up with this one. The same thing will be applicable to the standard normal distribution. Okay, so if we look at this page, here he converted z separately, z1, which is the minimum, and z2, which is also 1. So here between minus 0.8 and 1, but here we did it in one step. Okay, which I feel it is more reasonable and easier to solve. Okay, so here we come to the normal distribution, standard normal distribution table, and we'll get the readings of it. So it is 1, first z is 1, I get the area up to 1 from the table here, 1, and there is no decimals, so 1, 0, okay, it will be 0. The probability here will be 0.8413 minus, okay, the probability of minus 8. So go to minus 0.8, okay, minus 0.8, okay, it's 0 or something, no, minus 0.8 and 0, because there is no decimals also, okay. Up to here, it will be careful, you are checking minus 0.8, is not positive, okay, it is not plus, minus, so it will be 0.119, so we can get the difference between them, which will be 0.6294, okay, so this will be the answer. Okay, I think it's easy by having just listing them down, right? X greater than or less than 1300, and here 1525, what he given the question, and then minus mu divided sigma, minus mu divided sigma, minus mu divided sigma, and you can get the answer. Okay, just when you write it, just leave spaces. Okay, so you can write something here. Okay, because I have that area, I cannot leave long spaces. So 1300 minus mu divided sigma, and here minus mu divided sigma, and here 1525 minus mu divided sigma, and then you can convert one into z. So z, in one step you can get z. Okay, just to draw it for simplicity, to avoid any mistake, just to draw it so you can know which area you are going to calculate. So here this problem is also a typical problem. Here the time spent watching the TV by the middle of the school, normal distribution, has a normal distribution, not standard, of course. with a mean, and he gave us the mean and he gave us the standard deviation. The mean is 20.5 and the standard deviation 5.5. Watch, find the percent who watch the TV less than 25 hours. Okay, less than 25 hours. So he wants X less than 25 hours. To leave space, less than 25 hours. Okay, so just I want to convert it into normal. So I say X minus mu divided sigma minus mu, which is 25.5, divided sigma, which is 5.5. Then this will be Z less than, so that will be less than 0.82. Okay, so I come to the less than 0.8. So this is the standard normal distribution. This is 0. Any point, any place in the positive, but it should not be in the negative. So anywhere here it's right, but don't put in the negative. Okay, so don't take a lot of time to identify 0.8 is here or here or here, anywhere in the positive side. Okay, 0.82. So he said less than, so less than, it is right. So it is easy, we'll get it directly from the normal distribution, standard normal distribution table. We'll get it directly because it gives less than always. Okay, it gives from minus infinity up to here. So 0.82, I come to 0.8, and then but they have two decimal places, so second 0.02. Okay, because 0.882 equals 0.8 plus 0.02. Okay, so I still have this one, so I have to go here and go 0.2, get this reading. So the probability here will be 0.7939. Coming to B, watch more than 30 hours. Okay, so the same thing here, X greater than 30 hours. Okay, so let's leave some space, as we said there. X greater than 30 hours. Okay, so X minus mu divided sigma, 30 minus mu divided sigma. Okay, so here will be Z greater than 30 minus mu, which is 20.5, divided sigma, which is 5.5. So Z will be greater than 1.727 or 1.73. Okay, so it will be, because I need just two decimal places. Okay, so it will be Z greater than 1 point. So here it will be greater than 1.73. So I want this area greater than. So how can I get the area greater than? I have to get the area which is less than, then 1 minus this area. Okay, so 1.7, okay, and the 3 here, so I get this area. So it will be 1 minus 0.9582 equals 0.0418. Okay, I hope it's clear. Example C also, it will be the same thing. It will be between 25 and 30 week per hour. So I have already less than 15. So here, what he wants between 25 and 30, between them. Okay, I have here already got less than 25. I got already in C more than 30. Okay, so before doing, I can do the calculation. I can say X greater than 25 and less than 30 and calculate it. There is no harm, but I already, in some of the cases, if it is 3-4 points, maybe some of the cases this point depends on the previous, so no need to redo all the calculations again. So it is greater than 25, and so greater than 25 and less than 30, which is this area, and I have already this area which is less than 25 and the area which is more than 30, which should not include here. So in this case I can get the probability. Okay, I have already the probability here. I went with this probability. I can get the probability which is less than 30 from the normal distribution table, but after converting it into Z, I have it already here. Okay, 30, it was under the answer of B. Okay, the answer of B, I got it from the periodic table. which was this amount, C, which was this amount. So this is up to 173, okay? 173 with 30. So this is the reading, 173. Or if you want to calculate it, you can calculate it to avoid any confusion. I think better to calculate it to avoid any, I don't want any confusion to lose mark unnecessarily. Okay, so here we have the answer, which is this one, 9582. 9582, and the previous one also was B. It was from the table, it was 0. I've got it in A, it was 7939. So we can subtract them, this minus this. So this up to here, everything, and this one up to here. So we can get the area in the middle, okay? But let us calculate in the normal way, which we used to do, okay? It is the same thing, just even the same normal distribution, standard normal distribution table, you find your mark already there, okay? So X greater than 25, okay, and less than 30, okay? So here minus mu divided sigma, minus mu divided sigma, minus mu divided sigma. So it will be Z less than, okay? I have already calculated this 30 minus mu divided sigma in the previous slide. 30 minus mu divided sigma, it was 1.73, 1.73, and here it was 0.8 something, 0.82, 82. So I can go to the table, okay, the normal distribution table. Sorry, between both of them are positive, so both of them should be in this side, nothing should be in the other in the negative side, okay? So 0.82, and here should be 1.73. So this is the area which I'm looking for, okay? What is the reading at 1.73? I got it from the table, 173.9582. And what is the probability was there here in this one? It was 80, wait, not this one. Yes, 82. It was 7939. 7939. So it will be subtraction of this minus this, because up to here it's all the area here, okay? Again, I'm keep repeating just to, and up to here it is this area. So if I subtract this, all the area minus this, I'll get this area, okay? Okay, so it will be 0, the probability of between X more than 25, okay, probability of X more than 25 and less than 30 will be equals 0.9582 minus 0.7938, A equals 0.1643, okay? It is the same answer, okay? I hope it's clear. This D is little tricky because he didn't give us the time and said time more than or time less than. He gave us the probability. He said find the 90th percentile. So the probability is 90%. So he gave us the answer. The probability, he gave us already the probability 90% based on the standard normal distribution table. Okay? So I have to get this 90% from the standard distribution table and then convert it from Z to X to work it the other way around, okay? So the probability in this case will be equaling the probability of Z, because this is percentile, the probability of Z will be equal 0.9. So I have to find in the periodic table which one the probability is 0.9 and then work it the other way around. So in this case, I look in the periodic table to the one which equals to 0.9. He gave me 0.9. but there is no decimals here. So I have to get the most closest one to it. So if I look at the periodic table here, I find that I find that 0.9 doesn't exist here. I have 0.915 and I have 0.8997. So here it is very closer because it's just 0.003 far away from this. But this one is 0.015, which is more. The difference or the gap is more. So here this one is more closer. Okay. So this one will be my answer. So Z in this case will be 1.2 and 0.8. So 1.28, this will be my Z. Okay. So Z in this case will be equaling 1.28. But I know that Z equals X minus mu divided sigma. Okay. So 1.28 equals X, which is X in my case is the time. Okay. So let us write it in the bigger place here. So 1.28 equals X minus mu in my case, which is 20.5. The sigma, which is 5.5. So by having cross multiplication, I get that X equals 27.54. Okay. So X in my case is the time. So the time will be 27.54. So at this time, okay, he will be having the 90% percentile or the 90% probability of the time it is spent in watching the TV. Okay, at this time, which is 27.54. And here let us see the time in minutes or in hours. It's in hours. Okay, at 27.54 hours. So here in this problem, he said that in a population, the hemoglobin level of the adults men follows the normal distribution of the mean, and they give us the mean, which is mu, okay, and the standard deviation, which is 20, okay. Find the probability that randomly chosen men will have the hemoglobin level between 138 and 152. So he wants X greater than 138 and less than 152. I can say X minus mu divided Z, okay, less than X 152 minus mu is 155, okay, divided Z, which is 20, and less than 138 minus 155 divided 20, okay. So X minus mu will be Z, okay. If we calculated this, how much it will be? It will be minus 0.85, okay, and this one will be minus 0.50. Okay, so both of them will be negative. So that will be, in this case, that will be careful, don't touch x-axis. Okay, both of them will be in the negative side, so I cannot present them here. Okay, be careful. Okay, so it will be here. So the one which is closer to 0.15 negative, and this one will be minus 0.85. Okay, so I have to get the probability of minus 0.15, all this area, minus the probability of this area, so it will give me this one. Okay, because everything is measured to the left. We are keeping repeating just to remember. Okay, so here I have the values of that from the standard table. I can get the values. So I got at minus 1, okay, and then 5 in the horizontal, minus 1 from here, minus 0.1, and here minus 0.05, okay, and I get the value, the reading of it, which will be 0.4404, okay, and also I go here and check 0.85, okay. So when you come to both negative and the positive, be careful, because here this is 0, so the first one next to 0 is not 0.85. next to 0, 0.15 negative, then 0.2, 0.3, 0, up to 0.8, okay? So be careful which one you are putting to the left and which one you are putting to the right, okay? Because both are negative, so sometimes it's a little confusing, okay? So go to the normal distribution table and see for minus 0.85, so we'll go to also there and we'll see for minus 0.8, okay? And here minus 0.005, okay? And we'll find this value, which is 0.1977. So this will be the two values, okay? And this will be the answer. So here in B, question B, it said, what is the HP level of 15% of the population is greater? So the question here, just the wording in the question is a little bit tricky. So what is the HP? He wants the value. And he give us the percentage, like the percentile, the probability, okay? What is the HP of 15% of population is greater, okay? So if we have this value here, we can say, for example, this is 200, for example. Let's assume 200. So we can say all the people here, this percentage of the people are higher, greater than 200. If it is 150, we can say 15% of the people higher than 150. Okay? It is X, so we can say that 15% of the people are higher than X. So this graph, if we assume here, this is 85% of them here and 15% here. So because he's talking about the greater, so greater will be this side. So we have to only to have 15% greater, okay? Because the word greater, this is the problem. He said the word greater. So if we put it here, we'll have more than half of them, more than half greater. So it will be 65%, 70%, whatever, more than 50%. So it has to be in this side, okay? In order to be, look like less than 50%. So here we can assume this part is 15%. Up to here it is 50%, okay? So let's talk about the greater. Greater goes to the right, okay? Greater goes to the right. So I have to have, so I said 15% greater. So here this is the 15% greater, okay? So the other way, we have 85%, which is excluded, okay? So in order to get this number, I have to calculate the 85%. I have to calculate the 85%. So I have to go to the standard normal distribution and see which one represent, which Z value represent 85 percentile, 85 probability. It is the probability, percentage or percentile here, it is the probability. So the only point here that I have to understand, I have to find the 85%, not the 15%, okay? If he said less than, in the periodic here in the graph, he said less than 15%, sorry. If he said less than 15%, so I can say 15% here, and this is the less than 15%. But the problem, he said greater, so it cannot be in this side. It must be in the other side. It must be here, because he wants greater, so it will be this area. This area, in order to get it, I have to find the 85%. I don't have the full periodic table here displayed, but I have it in the previous slide. Okay, so here, if you go to, I want 85%. The probability itself is 85%. So where is the probability 85%? These are the probabilities, not this one and not this one. These are the number. These are the values, the X values which I have. Okay, so I have to find the probability from inside the table itself. Okay. So which value is 85 here? 80, 85.7, 85. The most one which is very closer to 85. Here, okay, this one is very close. Let us see if I have any other values which is closer. Okay, so before it, here only 0.008 and here 15. So this one is the most closest one, okay? So this one is 1. And what is the hundredth? 104. So it is 1.04. Okay, so Z equals 1.04. If I go to my question again, okay, here. So Z equals 1.04. Okay, so I have Z equals X minus mu divided sigma, the same thing which I'm saying every time. Okay, so 1.04 will be equals X minus mu, which is 155, divided sigma, which is 20. okay? So x will be equal 1.175.8. So this will be my sigma. So this is the blood pressure, which I have 15% of the people more than this. So here, if you look at the conclusion here, the conclusion, 15% of the adult men, because this experiment is for the adult men, okay? Of the adult men have greater high blood pressure level than 175, okay? So this is the point which is asking about. Coming to C, question C, what is the probability? It is a little tricky, but he already mentioned in the slide, in the theory part. What is the probability that individual have high blood pressure of exactly 170? This normal distribution doesn't give for individuals, okay? It doesn't give for the sample, for the sample which I have, okay, or for my population, but not for individual. I'm not dealing with individuals, okay? So what is the probability that individual will have exactly 170? It doesn't give to me, so the probability will be 0, okay? The probability will be 0 since it is a continuous random variable. I cannot take for one only, a spot, okay? And this has been mentioned in the theory lecture when I described it, okay? Thank you very much. And by this exercise or this example, we have reached the end of seminar 5.